All right, well, welcome back to Introduction to Websites using Python and Flask alongside Susan Ibach. I am Christopher Harrison. Now, up until this point, we've been building out our server-side components on Flask. We took a look at our Jinja templates, and we really got a very nice structure around an application to start doing all of our little trivia and storing and asking questions and so forth. But you know what we need?
Well, we have a basic problem. Somebody enters a question, and we have no way of remembering what question they gave us.
Yeah, we need somewhere to store all of that. Yeah, so where can we store this data?
We're going to need some sort of data store.
Okay.
So that's what we want to focus in on now. So up until now, we've been very focused on how do we communicate between the browser or users at the browser doing something, sending information back to our Python code, sending information back to the user. But there are times we need to remember what happened in between or from session to session. You think about it, if you're placing an order at an online store, well, we need to be able to remember what you ordered so we can ship it to you later. So we do need a debate to,
kind of a good thing,
to store that information. So what we're going to do now is we're going to talk about some different data storage options. And then we'll delve into one of them in particular so that you have at least a couple of different tools in your toolkit that you can use to remember values.
Perfect. I love it.
All right, so let's jump in. Lots of websites need that ability to remember data. If you think about it, order information on online stores, you can ship it when it arrives. High score tables on video games, just remembering your favorite products, what you looked at last time you were here. That kind of stuff happens all the time on websites.
Yeah, I basically say that websites really are just a front end to a database. When you get right down to it, that's quite frequently it is, hey, here's my facade, my database in the back, and we're just going to be sending data back and forth between there.
Yeah, exactly. Yeah. Now, there's a lot of different ways. You have so many choices, really, in terms of how you actually physically store the data that you need to remember when you're on a website. One of the options is store data just in a text file.
Yep, it's an option.
Yeah, you've got code. You can write code things, store it in a text file, and read it back when you need it. Mm-hmm. XML files, and I'll explain what XML files are in just a moment. We're going to get to that. Relational databases, that's definitely another popular option as well. Ed and I will explain what makes it a relational database in particular. And the idea of what we call NoSQL databases. That's another term you hear a lot. So we're going to basically take a look at each of these options, maybe a little bit of the pros and cons of these different choices.
I like it. Something tells me that NoSQL is going to have NoSQL.
You think there's NoSQL used for NoSQL?
I'm going on a limb here.
Then I'm going to go on a limb and guess that somewhere else there is SQL.
Okay, all right.
Yeah, so that's the corollary to that.
Okay.
So when you get down to that, trying to make the decision of which data storage option you should use, the answer is always going to be the dreaded, it depends. That is the generic, if anyone ever asks you, how should I do the following in insert programming language here, the answer is, well,
always.
It depends.
It depends.
It's the safest answer for everything. But in this case, it really is true. So let's take a look at those four basic options and just talk a little bit about what they are so that maybe you'll be able to make the right decision and figure out when it depends on what. At least you know what it depends on. So the first option is to use a text file. And if you, text files, usually just comma-separated variable files. You can open them up in things like Notepad. And they're just files that you can store right on the file system, same place that you're storing your code. And they can contain text data. As I said, most of the time we'll use these comma-separated variable or CSV files. And, so there's a typical sort of file there. And they work very well. If you want to store very simple data, it's a perfectly valid way to store information.
Yeah, if you just need a couple of notes, a couple of just very simplistic key value pairs, just someplace to just, throw some data, the text file will work.
It will, absolutely.
Yeah, not the most robust solution.
No,
but it'll work.
It will work. And if you took the Introduction to Python MVA, we actually covered in modules 11 and 12, we covered all the code you can use in Python to read and write from text files. So we have covered that. I'm not going to go through it again, but that is absolutely an option. So what we showed you in that course is a real world scenario that is sometimes used. The limitations, though, of text files, if we actually take a look at this sort of file right here, one of the things that you run into is, if you take a look at it, all the records, we've got a bunch of records at the top, and these represent different people and their ages. But underneath, I have some information about some companies. And the problem is, if I write a program that's going to try and read this information, one of the problems it's going to have is it doesn't know when am I looking at an employee record and when am I looking at a company record.
Yep.
So it's going to read Northwind Toys Company and think that's a person's name. And when it sees 11 Any Street, it might try to read that in as an employee ID or as an age. And then it's going to go, what's this Toronto, Ontario, Canada stuff doing at the top? And it's all messed up.
And on top of that, what you'd be trying to do is convert the age into a number. You're going to see 11 Any Street, and then all of a sudden things are just going to blow up at that point because it's not going to be able to convert 11 Any Street into a number.
Right, and this is why we say text files aren't a particularly robust way of storing data, because we have no way of saying what data type is this, what is this data. The programmer has to know how that data is formatted, and the person who creates the file had better create it right, because if they don't create it right, it's going to blow up when you try and read the data.
Absolutely.
So yes, it works, but not always going to be our best solution.
Yeah. I've spent a lot of time on Any Street, by the way.
Have you spent a lot of time on Any Street?
A lot of time on Any Street.
Yeah. So the other option, of course, if you're worried about, okay, I can't tell if it's an employee information or company information, a lot of people might choose to split it across two files instead. Mm-hmm. So if we look at this example here, again, we've got information on companies and we've got information on employees. And you go, well, hey, I can solve that problem not being able to tell them apart. I'll just put them in separate files.
I could see a lot of files being generated by the end of that.
Yeah, you can end up with a lot of files, and this will work. And another one of the things about this, and you will see that very naturally there exists when you start working with files and with data, but there's often a relationship between the data in the different files. Mm-hmm. There's a very good chance here that, that certain employees may work at Northwind Toys specifically. And some of these employees work for Tailspin Toys. So they're working at different places. How do I know that? By just looking at these two files. There's nothing to indicate which employees work at which company. I don't have a way of doing that.
No, you really don't. You really don't. I mean, you're basically just sort of on your own to try to figure out, okay, well, now which is which. And if you tried to then start inserting in some brand new rows, things could go sideways in a hurry there.
Yeah. And that type of data comes up a lot in different scenarios. If you think of customers who are placing orders at a company, if even in a trivia application like ours, we can sort of set up, you might be able to request different categories of questions, and then you get all the questions for that category. Just being able to do that, like what is the list of categories, what are the list of questions per category, can become very difficult if you're just using text files. But again, if all you want to do is store a few values so you can look them up later, absolutely, you can do it with a text file, it will work. So a couple of other limitations to be aware of when we talk about pros and cons. One of the other challenges is if you only want one record in the file, and the file has 500 records in it, guess how you find record 143? You read record 1, record 2, record 3, record 4, record 5, record 6, okay, I'm done now. Until you're
just doing this the whole time, just
exactly.
flipping index cards. No,
yeah, exactly.
Nope.
Just imagine, if the rule was, if you were trying to look up I remember there was a time in our lives we had these things called phone books.
A what?
A phone book, and you could look up phone numbers in them. But imagine if you wanted to get one number out of the phone book, you had to read all the numbers before it. That's going to be a very slow way of looking up somebody's phone number. So again, it's not going to be the fastest way to retrieve a single record. If you're always retrieving all the values, it's fine. But if you're constantly just trying to get one value back, that's again a place where text files start to fall apart in terms of not being the optimal solution.
Right.
Sorry, we covered that. For some reason I went backwards instead of forwards. All right, now let's take a look at another option. This one's sort of, it's interesting. It's sort of a transition to the world of databases, but so it solves some of the problems of text files.
Okay.
And that is an XML file. An XML, if we take a look at an XML file, if you take a look at this file, it may kind of look like some other code we were looking like this morning. Because
it looks kind of similar.
Yeah, it may look a little bit like, look, we have open and closing brackets. Angle brackets. We have the idea of opening and closing tags. This looks a lot like HTML when you open it up.
It does. It really does.
In fact, HTML stands for Hypertext Markup Language, and XML actually stands for Extended Markup Language. So it's intended to look like HTML. So that is quite deliberate. But what's interesting about XML is in the end, it is just a way of saying, here is some data. Whereas HTML is designed for you to tell a browser, hey, I want to put a text box here, and I want this text to be in bold, and I want to put a button here and create this form. The XML language is designed to say, I have a record, and this is a list of employees, and each employee has an ID and a name and is a company that they work for. So that's how XML is designed. Its tags are all designed to let you specify, here's the information that I'm storing.
So you're describing the data then, rather than what you frequently do in HTML, and you should try and stay away from it, but you can often describe in HTML how you want the data to look, but not necessarily describing the data. XML is all about describing the data.
Data, yes, okay. It describes the data. So if you take another look at this example XML again, now what's neat about this, you think back to when we had just a CSV file. Whoops, that's what I meant to do. So if I had a CSV file, this would have just been that I had Doyle McCarthy here, and then I had, two Jody Mills. Can't type, apparently. Apparently I should be drinking caffeine. So if I had done it that way, you can see sort of I get this would be what it would look like in a CSV file.
Right.
But how do I know that the value of 1 is an employee ID? I don't.
It's only based on position, and what would happen if somebody else who wrote into that file flipped those two?
Yeah.
You'd be in real trouble at that point trying to parse and figure all of that out.
Whereas, right, so if somebody put in Doyle, 1 instead of 1, Doyle, suddenly I'm trying to read the file, it's going to mess things up. The neat thing, if we look at the XML, is you'll actually see that I say, here's the value 1, but I specifically specify that's an employee ID. And this is also for the employee. This employee also has a name. And that employee's name is Doyle McCarty. So for each employee, I have that ability to be very specific and to describe, as you put it, it's describing the actual data, saying this is employee information.
Yep.
What am I telling you about the employee? I'm telling you their ID is 2, and that their name is Jody Mills.
And you can tell that without knowing anything else in advance. And really, even if you didn't know anything about XML, you look at that document, and it basically just describes, hey, this is what we got going on here.
Yep, exactly. It's fairly intuitive. Building them for the first time is always a little confusing, but it's funny. If I'd handed you that file and said, what do you think this is? You probably would have figured out it's a list of employees, and that's their IDs and names. So it's also very self-describing, and that's another nice thing about XML. So those tags said describe the data inside the file. So we can see those different names and IDs. The other interesting thing about XML is we can mix and match different types of records in a single file. So it's perfectly valid. In this case, I have a list of employees, but they all belong to the company. So I specified, first of all, first I have a company, and that company is Tailspin Toys, and here's all the employees that are part of that company.
So those elements act as containers then?
Yeah, I'm sort of showing a parent-child type relationship almost. So it's like the parent company here, for his parent company of Tailspin Toys, has this list of employees. For this company, here's the list of employees. And along the way, I can provide you information about each company and information about each employee. And anybody reading the file can tell which employees go with which company. I can tell if it's company information or employee information based on where it's located inside the file and how it's described.
And you can even kind of keep going with that hierarchical structure where you go in and say maybe here's the employee and here's the people that they manage and the people that they manage and kind of break all of that down. And then through code, you can kind of explore all of that and bounce your way through the XML file.
Yeah, absolutely. It's not limited to one parent-child. You can have grandparent, parent, child, grandchild. Yeah, you could show this company has these departments, those departments have these employees, those employees have worked these shifts, and go as far down as you want. So that's the idea of XML files. Now, the other thing we mentioned there was a problem with text files is if you wanted to retrieve one record, you had to read the whole file. One of the neat things about XML is it has a query language. So there are specific languages and commands you can use to query XML files. There's XPath and XQuery. So XPath basically allows you to specify a path that points to the record you want, whereas xquery literally allows you to say, go look in the file and find a record that matches this set of criteria.
Yeah, xquery is much more robust than XPath. You can actually do kind of a couple of really cool things with XPath and go in and find attributes and so forth. But if you really are trying to get that full power and do things like for loops,
or say, get me all the companies in Tailspin Toys. For example.
Exactly. Yeah, just those companies. xquery is going to give you the ability to do that. XPath will point you to it, and then it's still up to you to go in and read the rest of those values. xquery will really let you get into all of that. And you'll notice that most of the surrounding technologies with XML start with the letter X. They just, yay!
XML, xquery, XPath.
Yay, letter X.
Yes. It's really good when you're playing the alphabet game, because I can never come up with enough things to start with X.
And today is brought to you by the letter X.
That's right, or at least this module.
Yes.
So we have these languages and these that we can use to query and get individual records back. Right. So that's, again, another improvement over basic text files. Now, in terms of drawbacks, XML files can get very big.
Yeah.
They're picky. If you forget to put the closing /employee on there, then when you try and query the XML file, it goes, I can't read your XML file because somewhere you forgot to close a tag.
They're also case sensitive.
Yeah, they're HTML isn't case sensitive, XML is.
Yep.
So those types of things, so they're very finicky about the syntax. If you forget a closing element, then it just comes back and says, I can't read your XML. It is case sensitive. The files can get quite big. Those are the drawbacks. But as I said, certainly much more powerful and can be more efficient than straight text files.
Absolutely.
There's some libraries out there that actually support working with XML files. So if you want to explore this, two of the more popular libraries that contain functions that allow you to do things like xquery and to read XML files. Beautiful Soup. I love the names they come up with for libraries in Python. Beautiful Soup,
Beautiful
of course.
Soup.
No soup for you.
Wow.
And LXML. Hey, come on, you're not the only one who can make bad 80s television references.
Yeah.
Come on. So an LXML are two popular libraries which will help you out. So if you want to try XML files, we're not going to cover it here. There's too many data store options for us to cover everything. Plus XML, there's actually a lot to it, and we could. Is there an MVA out on XML yet?
Yes. No, maybe.
We'll find out.
Processing.
But literally, you could do a full day course on XML without any difficulty.
Something tells me we probably have.
Yeah, we'll find out if there is an XML course. We've got a challenge for Christopher there as I keep going.
Hey, there's a developing Microsoft Azure Solutions on the 19th with Brett Statham and Sydney Andrews. That should be fun.
Okay.
It doesn't look like we do.
Okay, so we may have a new MVA idea to come up with. But there is a lot to XML. So again, it's one of those ones, if you want to delve into that as your option for storage, you'll want to take some time to learn that and spend a bit of time learning your way around. The next option, and this one's extremely popular and used in a lot of any of the really big sort of enterprise solution websites, and that's to use a relational database. So this is what you're going to see if you're going to a store and you're ordering things online. There's probably a relational database on the back end. If you're using a company expense reporting system where you enter your expenses, that's probably all being stored in some sort of relational database on the back end. So relational databases, they're made up of one or more tables that contain data. So if we take a look here, I've sort of got two tables. The first table here, this is sort of my customer table, if you will. And for each customer, I've got an ID, I've got a name, I've got a city for where that person lives, and I know the country where that person lives. Mm-hmm. And then I also have a orders table, which is keeping track of the orders each customer placed. And there is a relationship here between the two. You can see here that Satya, being inspired by our MVA, has decided to purchase himself a book on coding with Python.
Wow, we have that kind of influence.
I know. You just wait. We'll see what Satya's talking about in his next webcast. And Susan, on the other hand, was so inspired by all this cool stuff that Christopher's talking about that I had an urge to run out and pick up a book, because you can see that I have a ID of 106 and customer ID 106, purchased the book on building websites.
Okay.
So I have one or more tables, but there's relationships between the tables, right? I know which customers are going with which orders, and that's what makes it a relational database. So there's always going to be, or there's frequently going to be two tables, and there'll be one column that exists in both tables. They don't have to have the same column name. In the customers table, the ID column is referenced by a customer ID column in another table. So again, looking at the slide, you can see that we have an ID in the customer table that allows us to tell which orders were placed by which customers.
Absolutely.
So those values, that's why it's a relational database. That's actually where the word comes from.
Exactly. One little thing, only just because it's me and I've got to say it. Typically when you see those column names, they won't have the spaces. We did that for readability, but yeah, you might not see the spaces there.
Yes.
It's one of those little
I
things.
understand, yes. Even though some databases will support spaces and column names, I'm completely with you on this one, Christopher.
Yeah.
As a person who spent many years working with databases and as a coder, I really don't like working with column names that have spaces. So be nice to fellow developers. Don't put column names or spaces into your column names.
And don't do underscores either while we're at it.
Yeah.
I don't know about you, but at least for me, hitting that underscore when I'm trying to touch type, it usually takes me about like 5 shots before I can find that underscore.
You see, we can't stop ourselves. Relational databases is another big topic. There's like a whole MVA on that.
There is. Somebody posted that we should have a T-shirt that says, there's an MVA for that.
Absolutely. That'd be an awesome T-shirt. I can see that coming soon to a store near you, or at least a laptop sticker. I like that. There's an MVA for that.
Mr. Calder, paging Mr. Calder.
When we wanted to read values from a text file, we would have to read through the entire file. When we wanted to read a value from an XML file, you could just read the entire file line by line until you find what you're looking for. Or we mentioned you could use libraries and XQuery to request, say something like, get me all the employees in company Northwind. In relational databases, we use a language called SQL. Aha. So this is why
there's the SQL. So
this is where.
Okay, gotcha.
This is a yes SQL database.
Yes SQL database.
This is a yes SQL database instead of a no SQL database, because SQL, or structured query language, also sometimes just called SQL. This is the language we use to ask the database for information, to insert and manipulate the data inside the database. So you can say, give me all the customers with a particular, or all the orders for a particular customer. I can say, go add a new order. I can say, delete an existing order. So again, you just take a quick glance at the slide. You can see a basic example of a SQL statement. Select star just means select all the information for Bill Gates from the customers table. So not going to teach you SQL here. I know there's an MVA on SQL out there, but that's how we communicate with a relational database. What's great about relational databases, you can store very, very large amounts of data very efficiently. That's what they're good at. They're good for storing large amounts of data and letting us query it in a very efficient manner. You can also keep track of the relationships between all of the different records. Who ordered what? Who works for who? Which account belongs to which customer? That's what relational databases are really good at. You can also search for exactly the records you want. The database tool is actually going to be able to find the record you want and give you back just the record you asked for. So that cuts down on the amount of data that's being sent back and forth, and it makes queries faster and less traffic on your network.
Yep.
And these days, hey, with all our mobile phones, we're all starting to care about that a little bit more.
A little bit.
So you get back only the data you need. Now, that all sounds awesome. You're like, wow, it does everything I want it to do. So why don't we always all use relational databases? Well, if they do all that, they have a little overhead involved. If you're going to use a relational database, it's actually separate software. You can't just go into Python and say, create relational database and start querying it. It's going to be separate software that you have to install somewhere on a server in a place where your Python code can connect to it and access it. So examples of relational databases include SQL Azure, SQL Server, Microsoft Access, MySQL, Oracle. Those are all examples of relational databases, but that's a separate product. You have to go install SQL Server, and then you have to create a database on SQL Server, and then you have to create your tables, and then you have to load it with data, and then you go to your Python code and you say, connect to that database I made over there. Go look in the table I made over there and start inserting data into it. So there's a lot more upfront work involved.
Yeah.
It's great once it's all up and running.
Yep.
But if all you want to do is store the high score for a game,
yep.
My gosh, that's just major overkill.
Yeah.
I want to create all that just so I can store a high score. There's one. Let's keep it simple.
So basically what the main point that we're trying to make throughout all of this is, there's that old saying, if the only tool that you have is a hammer, everything looks like a nail. And of course, that's not the case, that a hammer is good for a particular task, but you also need screwdrivers and pliers and everything else. And that's really what we're trying to do here, is just kind of show you, hey, look, these are all the different tools that are available for you, and they each have their different advantages, disadvantages. They all have their different places and their different purpose.
Yeah, and we're just trying to help you understand which one's right for the different scenarios you're going to encounter as you start building more applications.
Yep.
The next option would be to use a NoSQL database. It's funny now, I always call it NoSQL, never NoSQL. It doesn't sound right that way. NoSQL just rolls off the tongue better.
There you go.
So a NoSQL database is basically, it's a database that stores data. So obviously these are all used for storing data, but it doesn't store them in tables with relationships the same way the relational database does.
Right.
There's a number of different ones out there. If you've ever heard people talking about Mongo, again, I love the names of things, Mongo and Jinja and all these wonderful things. You really can completely confuse your friends. Post something on Facebook about the fact that you're learning the difference between Mongo and NoSQL versus using XQuery on XML, and I promise you, your friends will just look at you completely stunned. But if they understand you, all right, you found a fellow geek. So you can create, there are databases like Mongo is very good at storing documents, if you want to store a lot of documents. Or if you need to do a lot of graph stuff, there's OrientDB, which is designed for that. Or maybe just key value pairs. So I just want to remember a few values, and I can want a name for each value so I can remember which value goes with the thing. So I want to know first place score, second place score, third place score. Then I can do that with what we call key value pairs. Mm-hmm. And Redis is an example of a key value pair database. And MongoDB, actually, you can absolutely use for key value pairs as well. It's another popular one for that. Now, this is my pet peeve, though, is I meet a lot of startup companies. And initially, they're starting out. They don't want to spend the money or the time to build that infrastructure of a full relational database.
Yep.
So they start off with a Mongo or a Redis. Awesome. That is great. And then as their website gets more complex and they're trying to do more and more things, they start trying to basically do weird things with their Mongo database to basically try to get it to do all the things that relational databases do automatically.
Yep.
So absolutely, Mongo and Redis are great, but when you do, as it gets bigger and you find yourself going, wow, it isn't doing what I want to do, I'm going to have to come up with some creative way to rework around that, stop yourself and go, wait a second. Is this getting big enough and convoluted enough? Maybe it's worth the infrastructure of a relational database, because I've seen so many companies said they start off with NoSQL and then they're so caught up in that they start writing thousands of lines of code to try and do things that are all done for you if you just use SQL.
Right. And, kind of going back to something that we talked about earlier with design, that one of the main points that we made was that separation of concerns. So our views display out the data. One of the big things that you could do is when you set up the methods inside of your routes file or files, if you've got multiple, one of the things that you could do is really, again, just call out to a separate class or to a separate Py file that has the functions that do all of that behind the scenes. Because when I get into my routes Py file and I go in and I say create, if I've got a little method that's going to store that inside of a database and I've got another method that's going to pull that back in from the database, I don't care where that database is, just so long as I know that it's going to store it, and when I ask for it back, that it's going to give it back to me. So what's happening behind the scenes really just becomes a black box to me. And if you design properly, what you can do is make that black box pluggable. So that way maybe you do start out with Redis or with MongoDB, and then you start to grow and you start to get a bit more complex and you start to realize, hey, wait a minute, we really do need to migrate over to, let's say, SQL. Well, you can do that with limited impact on the rest of your application, that you go update the data access portion, but you leave everything else the same. And again, my code, all I'm doing is I'm just simply saying store question, retrieve question, or whatever your calls might be. And as long as, again, it's going to store the question and retrieve the question in that little black box, I don't care what that black box is. I don't care where it's doing it, as long as I'm getting the behavior that I expect. So you can make those those types of changes from database to database and limit the amount of impact that that's going to have on your application.
Yeah, that's where good designing your code. To, you may have somebody on your team who's really good at figuring out how to talk to databases, or when you're really good at that, or you're really focused on that code. Yeah, make a module that's making the connection, asking for the data, and passing it back in a function. And then yes, in your other module, you say, hey, get me that value, would you? And yes, it'll make your life easier when if you come to a point where you need to change data stores. And you'd be surprised how often that could be useful. Now, so Redis, if I take a look here, is an example of a key value paired database, where it said, great if you just want to store a series of values. So you can have something very simple. So I have a value. I want to keep track of a number of people who visit my website. And so what I do is I have a key, and for that key, I store a value. So basically, I just have number of visitors. It's like a variable, really. And key is like my variable name, and the value is the value I'm storing in the variable. The only difference is I'm storing it in Redis, and we call it a key value pair instead of a variable and a value. But aside from that, it's really the same. You can have some more complex names as well inside there. For example, I can actually start creating sort of structures of my variable names if I want to. So here, whoops, wrong one. I have actually created a variable name or a key, which is user:first name. This is actually quite common in Redis. A lot of people use this convention. It's a way of just sort of saying, I want to keep track of all my user information. So I might create a key called user:first name and a key called user:last name. So I remember, but both of those keys are information about a user. So you can create sort of a structure to your key names to help you keep them straight. One of the most popular key value databases out there is Redis. And that's actually the one we're going to use as the backend for our database that we've been working on. So, but remember, the data store is not part of Python. One of the great things Christopher talked about this morning was that one of the reasons we liked Flask and we liked Python was you can get started with it really quickly because it's very minimal, but that later when you needed to do extra things, you would need to add more components and install more pieces. So if we want to use Redis, we're going to have to install it. To install it, there's a few things we'll need to do. One, you literally need to build the Redis database or Redis product on your machine. So,
the Redis server.
Yeah, the Redis server. So you're going to need to go to, easiest place to find it is off GitHub. There's the link for the Windows setup file. There's different ones for different types of operating systems. This is not a Windows-specific product. And then once you've got that installed on your computer, you're going to need to install the Redis library in your Python project so that your Python code can use the methods that are used to talk to Redis. And we're going to need to add that package to our virtual environment.
Somebody actually asked this in the Q&A during lunch, was, hey, so I downloaded Module 5 or whatever it was, and it's saying, hey, I don't have Redis. How do I get Redis?
Aha!
So,
well, let us answer that question.
Yeah.
And the last thing you're going to need to do is you're going to actually have to make sure that the Redis service is actually running on the computer as well. Because installing software doesn't mean the software is running. So we're going to have to go to Task Manager and make sure Redis is running. So what we're going to do now is I'm going to flip over to Visual Studio. And what I need to do is I'm going to need to go over to my environment here.
Now, you've already got Redis installed.
I did.
Yeah, you've got Redis installed and up and running.
Yeah, so I'm going to show, but I will still show how you check if the service is running. But yeah, I have already done the step of installing Redis because I didn't want to sit here and have to do the little install. Oh, so wait, was it a different dance for installation while you're waiting for things?
It's more.
This was the slide dance. This was the slide dance.
Yeah, we're not going to do this.
Okay.
But it was sort of like a. And now I'm trying to remember.
It was sort of this sort of thing. Yeah,
more of like the head moving.
Right. So
because you're moving the mouse along with it, so your head just kind of wants to bob along. With it.
I can't keep up with Christopher's dancing skills, so rather than having to do an installation dance while you watched it install, I pre-installed it.
By the way, excuse me, Mr. Barry. This is not to wind up on outtakes. That's all I'm saying. Okay.
All right, there we go.
Yeah, it's a good thing we're not live.
Good thing we're not live, absolutely.
Yeah.
So what I will need to do is I still need, so I've got Redis software installed, but I need to make sure that the service is running, and I need to add Redis to my Python environment. So let's start by installing it into that Python environment. So I'm going to go to my program, and I'm taking the same project that Christopher finished up with at the end of the last chapter.
Yep.
I'm going to my environments, right-click, and saying install a Python package. So we'll do that, install Python package, and literally you just type in Redis, because that is the name of the package. When you select that and you select OK, it will go ahead and you'll be able to see in the bottom little left corner in the output window, Redis was, in fact, installed successfully. And I can confirm that by taking a look over here in my Python environment. And you can see Redis added to my Python environment as well. OK, so I have the Redis package. I need to make sure that the service is running. I do that by bringing up Task Manager. And inside Task Manager, I'm going to go to my services. And I'm just going to check in order. I'm going to do this alphabetical order here. Scroll down to the R's. And sure enough, there is my Redis service. And it is currently running. If it wasn't running, I would just right-click and say Start. If you're at a big company, you might occasionally run into problems where you don't have permissions to do that. You might need administrator privileges to do it. But if you're working on your laptop, that shouldn't be a problem. So I have it installed. I have it added to my environment. And I have the service up and running. So how do I actually write code to connect to it? Well, I'm going to need to import the Redis library so that I can access the coding environment. Just like we had to import Flask and import the use for and import render template, we're going to need to import Redis. Then we have to create a connection to that Redis data store using a function called strict Redis. And the syntax is pretty straightforward. It looks a little confusing, but the nice thing is there's very little you ever have to change here. So this falls into the category of the cut and paste this line of code, and it's probably just going to work. So I'm creating a connection. I'm calling my connection R in Christopher speak. Yes, it's great for talk like a pirate day. That's not till September, though, gentlemen.
Just
Redis.
taking all the fun out of my day. Every day can be talk like a pirate day when you call your connection Redis to R. Absolutely, and every day is like Sunday.
Yeah. So we go redis.strictRedis. So strict Redis is the function we're calling to create our connection. And we have to specify where is this Redis service running? Well, I've got it running on my PC, so it's on localhost. So the value I type in there has to be the name of the machine where it's running. I said I have it installed locally, so that's just called localhost. It'll be the same for you. The port number is going to be 6379, and the database number is going to be 0 because I haven't created specific database, new databases in Redis. So really, you can literally cut and paste that line of code. That's how you're going to connect to your Redis database as well. The only thing that might change is if you have it, if I was trying to run Redis and it was installed on Christopher's machine, I would have to find out how to type in the address of his machine instead of localhost. So if we try it, because that's really the test. And I go in here, let's see, and first I have to import Redis. So once again, I'm going to need to import it. And what I'm going to do is, let's start off initially, I'm actually just going to, when we go to the main page, I'm just going to connect to Redis right there.
Perfect.
All right, so I'm going to create my connection R. Sorry, I can roll my R's. My mother from Scotland, so I can roll my R's very well. And call it redis.strictRedis. And the IntelliSense does pick up that function name. And it's awesome. I love the IntelliSense here as well for helping me remember what the values are I have to enter.
Hooray, IntelliSense.
Yes, love IntelliSense. And the host is going to be localhost.
And while she's typing this in, it's worth mentioning that those values, the localhost, the ID, the port, and then the database, are the default. So you could actually just say strict Redis, and in theory it would work. But it's always a best practice to type those types of things out because you never know if maybe the defaults will change a little bit later. So so you've got it just like that. And then the other thing that I wanted to mention is that those first three parameters are positional. So you could have just gone localhost, port, and DB. But again, it's nice to type it out as well. So that way, if somebody else comes along, maybe they haven't done Redis before, they can look at that and they go, oh, okay, well, there's the host, there's the port, there's the database.
Yeah, absolutely. So this line of code, I'm going to show you 3 different lines of code. They're all equivalent. I could have actually done this and just said, call strict Redis.
Yep.
Whoops. But have to, we all know Python cares about the positions here. Or I could write this line of code this way. as you were saying, because localhost parameter it expects, port is the second parameter expected, and DB is the third parameter expected. I don't actually have to tell it. Those are the values for a database, port, and host.
Exactly.
These 3 lines of code are all equivalent. So I'm just going to comment that out here, and I'll just make a little note here. Alternate ways to connect to Redis.
Sort of like the movie Clue with 3 different endings.
Each command is equivalent, really. Totally personal preference. The reason I like to list it is because it helps me remember.
Equivalent.
Eventually I will spell the word. Is it helps me remember what those parameters are. And that way, when I haven't looked at Redis for all that time, it's easier to come in. Christopher's losing it over there.
Every time now we say R, it's just,
Okay, we talk like a pirate day now for the rest of the day. So.
Hey!
Arr.
Arr.
We'll get eye patches for the next module. All right, now how do I know if it's worked? Well, actually, to be honest, I mean, you could start writing try-catch statements here.
You could.
And saying if it does, but really, to be honest, this is the simplest way to test it. Run it. If your web page comes up, you connect it. If your web page does not come up, then you probably didn't connect.
That seems pretty simple to me.
It's pretty straightforward. So if I just go ahead and run our application, of course, needing to rebuild it along the way. And there it's off and running. It's trying to connect. And look, I can go in. I can start creating questions. I have successfully created a connection to Redis.
Well done.
So at this point, I think what we'll do is...
What did we learn, Susan?
I was going to say, let's just sort of take a look at that here.
What did we learn?
So we've got it running, but we learned about sort of some different data storage options and some of the pros and cons between them and how to install Redis and connect to it.
Okay.
So I'm going to now quiz you to see what you did learn.
So
aside from the fact that it's now become Talk Like a Pirate Day.
Okay.
If you had some scenarios, I'm going to throw some scenarios at you, and I want you to think about which of the data storage options we discussed you think would be the best option.
Okay.
Because that is one of the things we've tried to do.
Okay.
If you're building an online store that sells DVDs and books, and you want the user to be able to see the list of books by author, subject, price, or publication date, which of our data storage options do you think would work?
I'm seeing a lot, and one of the things to highlight, if I can just tangent. Tangent mode.
There we go.
There we go. So over here on tangent mode, one of the things, that's sort of worth mentioning, like Susan had highlighted earlier, is that we could use really any of these databases for all of these possible solutions. So now bringing it back to the original question, because of the fact that you've got all of those different types of data and so forth, I would say you would want SQL Server.
Yes, I think that's good. In this case, a relational database, such as SQL Server. All right, I like that. Okay, you're building a quiz website.
Okay.
I like that, whatever happened, I don't know.
Hey.
And you need to store the questions and the correct answers to the questions.
In this case, because of the fact that we're going with just the very simple questions and answers, I think Redis would really be the best option there.
So a NoSQL database.
NoSQL, that key value pair.
Yeah, you could use a relational database if it was a really complex, if it was something using to store exams and exam questions for a university, you could do that if you wanted to.
Exactly.
Yeah. You want to keep track of the number of visitors who came to your website. It's the kind of thing people often do. They just want to store a number of visitors.
If that's it, just a number of visitors, toss it in a text file and be done with it.
Yeah, if that's all you need, sure.
That's it. Yeah, single value, toss it in a text file.
Yeah, absolutely. If you're already using
it in a text file,
if you're using Redis for something else already, then you could store it in Redis.
Exactly. Yeah. Yeah, and that's it. Is that if you were doing a lot of different things, it's not like you have to say, well, one type of data is going to go over here, one type of data is going to go over here, one type of data is going to go over here. You can decide this is the data store we're going to use and put everything there. Or again, you could, in certain cases, move different types of data into different spots. So if you just needed, like caching key value pairs, Redis cache, hey, there you go. Redis would be perfect if you're looking for just a single symbol value. You could toss that into a text file. So, you really don't have to decide on one solution and just be locked into that. You can go with a lot of different solutions.
Yeah, absolutely. And so, awesome. So what did we learn? Basically, we learned some of the pros and cons of our different data storage options, text files versus XML files versus relational databases like SQL Server or NoSQL databases like Mongo or Redis. And we also learned how do you actually install Redis and connect to Redis using that strict Redis function. So what can we do with this? You can now install Redis, which you're going to need to do if you want to keep following along with us, because next module, we're going to learn how we can actually store our questions and answers using those Redis commands. And we learned how to create a connection to our Redis database from our Python code.
Absolutely, yeah. So we kind of got nice and rolling. Now I am going to real quick here, one last time, I am going to go into tangent mode. Only because I just want to highlight real quickly that once again, this is the first time that we've been doing live closed captioning on our MVA, on our live Jumpstart. And as a result, we're trying to kind of gauge feedback and things like that. So if it's not there right now, sometime in about the next 30 seconds, he said, pausing long enough. There's going to be a poll down at the very bottom asking about the closed captioning. So if you found that it's been helpful and so forth, please let us know. And be honest, if there have been issues, let us know that as well, because that's the way that we're going to get better. Okay, cool.
Awesome.
So with that, what do you say we take a break, and then let's come back and actually put some questions into that Redis database.
Yeah, let's start storing some data into Redis.
Exactly.
I like that.
Yep.
So, awesome.
Perfect. All right.
We'll see you soon.
We'll see you in 10.